All right, so what you're looking at here is a 2002 Chrysler Concorde power seat circuit. And what I'm going to show you towards the end of the video is this power seat circuit isn't all that different from a power door lock or a power window system. So the diagnostics of this particular wiring diagram, once again, is ubiquitous with a lot of other vehicle manufacturers and a lot of other circuitry. Now there's many ways you can skin this cat, but here is what I would consider one of the better ways of doing it, assuming you have access to the loads. So whether it be this power seat motor or power door lock or power window, if you have access to those, is probably the quickest work to diagnosing whatever's wrong with this circuitry would be how I'm going to show you. And maybe again towards the latter part of the video, I'll talk about some other practical methodology when you have access to, say, I'm thinking in my head here, primarily of just the switch itself. So you're not that deep into, the door panel yet. So there is that variation, but that in mind, let's go forward here. So here is the actual circuitry. Now, and I'm going to move to a simulation again that I have made, but I want to show you the actual circuit here before we go to the simulation. So each motor and its pair of single pole double throw switches repeated 4 times. So they have a common power coming in, and then inside you see that rail for the power inside the driver's seat switch, and then they have a common ground. So with that in mind, let's switch to the simulation mode. Okay, so to just get you orientated here, here is the driver's side switch assembly right here. And you've got the 2 single pole double throw switches. So they don't move in tandem. So when you're pressing up, right, this switch moves. If you're pressing the down or forward and reverse, depending on, if you're dealing with a power seat horizontal motor, they move separately. So you see here I have some faults put in on either lines coming out of the switch to the motor. Now the motor, I made them LEDs pointing in opposite directions, okay, and that will give you an indication of this motor. You don't have one motor for up and one motor for down, or one motor for forward and one motor for reverse. It's simply a reversible DC permanent magnet motor. All right, so you switch the polarity, it rotates the other way. So the visual cue here would be LEDs opposite each other, and you will see one light with one polarity and the other light with the other polarity. And in this green area here, it's a connector, and I will simulate pulling off the connector. And we have our voltmeter here and another voltmeter here. Again, you'd only have one, you just switch it, but I'm putting both in here now. And what we have on both of these voltmeters, and this is going to be a common theme, again, power seats, power windows, power door locks, it's a common theme because they're all wired, almost all of them are wired in nearly an identical way. So the positive of your voltmeter is connected to the positive of the meter, and you're probing the 2 input wires to the motor. And the reason why is when you're not touching these switches, look at where the lines go. They go straight to ground. And on this side here, straight to ground. This is the position of these switches when you're not touching them. So it makes sense if right at the motor, you test for a path to ground. And how you can test for a path to ground with a voltmeter is the positive on the positive lead of the voltmeter onto the positive of the battery, and then you just probe for that ground with the negative probe. And if you have that completed path, you'll get 12 volts. So let's turn this thing on and have a look here. So now it is live, and you'll see here we have 12 volts on both leads. And I'll just show you it working here. So you take a look at these LEDs, and these colors of these arrows will move. So you'll be able to see the polarity. So I'm going to use the U key. So this is we're moving up. All right, and you see this little LED here. It's green and it's pointing up. Don't worry about the voltmeters just yet. I just want to show you. And down, all right, little red LED and it's pointing down. And that's just simply a polarity change. So now you visually see that motor would be rotating in the opposite direction. So what I suggest is having your voltmeter connected like this, red on the positive, and the negative probing the ground, or probing for ground, up the wire through the switch to the common ground here. And when you do that, that's what you'll be checking this entire run from the motor. And you do the same thing on the other side. to check this wiring, and then there again through the common ground. And if it is fine, you'll have 12 volts on both sides. Now, there's one caveat here, and I'm going to right now induce the fault so you will see what I mean. So I'm just going to open this wire right here. So now we induced a fault. And you'll notice these voltmeters didn't change. So let's take a look at the easier example here. From this point, we do have a path to ground, so that should be 12 volts. But you'll see here, we don't have this path to ground anymore. Unbeknownst to us, this wire's broken. This is the fault. We don't have a path to ground through this way, but yet we still have 12 volts on this meter. So it sounds like what I had suggested doing might not work. And let's do it the other way. Let's just open this other fault. Same thing. So now we've just reversed the order of the problem where we have a path to ground on this line. We don't here, yet it's still showing 12 volts. Still not giving us any indication that anything's wrong. So let's just go back to fault 1 here. So this key is now open. What you have to remember to do, and this is why they're both 12 volts. Electricity will take any and all paths getting to where it wants to go. In this case, it wants to go to ground here as far as this voltmeter is concerned. Now, we wanted it to go through to ground through this means. That's what we wanted to check. Electricity isn't always cooperative. You got to step back and take a look at the circuit. Why is this 12 volts if this is clearly open? Where is this path to ground supposed to be? Well, it's right before your eyes. We wanted it to take this path. It couldn't. We didn't know it. We couldn't tell with this voltmeter that it wasn't. What happened is it backfed through the motor. Again, I've just got these LEDs here. I've got them set to trickle a little bit. So it shows, the voltmeter shows up a lot more accurately as if it really would on a motor as opposed to actual LEDs. So I've got these things set to have a little bit of leakage. So it actually shows up how it would for you on an actual motor. So what's happening is this current is backfeeding through the motor and it's going up through this line. And that's what you have to remember to do. When you are checking this circuitry, have a look and make sure that this electricity can only be following that this path you want it to follow, the path you want to check. So this is why I state, and this is why I have this connector here in green. We're going to open this connector now. This is why I state you have to unplug and isolate that circuit. Now you see, as soon as we unplug that connector, this went to 0. It in fact doesn't have a path to ground. It was backfeeding through the motor. Now you may say, hey, you didn't disconnect this. If you pulled this connector, both wires would come off. Yes, they would. But all you need to do is prevent backfeeding. So it really only requires you undoing one. Now, in a real world, this connector is one connector and 2 wires go through it. So you'd be disconnecting them both at the same time. But for this demonstration, I'm just doing one to not clutter the things. It's the same thing electrically. So you can see the key point here is disconnect the load. All right, so let's just put this back. And it doesn't matter. I'll prove it to you. So now we're going to have a fault over here. On this side, it's still 12 volts. Disconnect the load. We disconnect the load. This voltmeter does exactly what you think. It doesn't have that path to ground. So now you know, once you've disconnected it, you know which line has lost its path to ground. So you've literally carved this problem in half. And then from there, you would check it at the connector. If it had no voltage or no path to ground, this would read 0. And if you moved up to this pin on the switch, for example, and then all of a sudden you had that 12 volts, well, you know that this path to ground is good. So the fault would be between this pin and this pin, as an example. Now, I will say, practically, if you can check it from this motor, again, like I previously mentioned, you can check this entire line, all right, and check this entire line. If you are only able, at least at the time of testing, because you haven't got this whole thing ripped apart, only able to test at the switch, which is most common. You can't necessarily check it this way. You can check it for ground from the switch all the way through the switch and to its ground, and you can do that on both sides. But you haven't checked this other lead. So it could be this pole and this contact point here where it's connected to ground is fine, but maybe this positive one is burnt. And you would have to check this by the other means. Obviously, when you're moving this switch to the down position, let's do that. This voltage here is 12 volts with respect to ground. So you wouldn't put this voltmeter on this way. But that would be an easy check for that. But you wouldn't know necessarily at that point the condition of these wires and this wire here and the motor. Right? So you aren't able to check all of this stuff down here via only these two types of connections. You're doing a lot of voltmeter lead, moving around positive to negative, switching around pins. So it's a lot more difficult if you have to do it that way. But you can still get a lot done by simply connecting the voltmeters this way and then just probing those two lines, whether you're all the way down at the motor, ideal because you can just check more on the same test, or up here at the switch. Just understand, that's an initial test. Now, depending on what you have from there, you may have to, if you're up at the switch, now you can check these lines. So sure, you can unplug this whole gang switch, send power down, right? And if that motor doesn't turn, you know you have a wiring problem or a motor problem. And as well, again, you haven't tested the validity of this pin here or this pin here to flow the proper amount of current. You haven't checked these switches in all their different positions. But as a quick initial test, all else being equal, if you do have access to that motor, you can do a lot of checking down this way, and it is quicker, all else being equal. Okay, now let's get back to the diagrams, and I will show you a power window circuit, a power door lock circuit, how they are all wired this same way, where both sides of the load, when you don't touch the switch, is connected to ground. So this is a rather complicated diagram. This is a 2010 Hyundai Elantra. So down here, this orange and gray wire, these are power window circuits. So there's a power window motor between these 2 points, these 2 points, and these 2 points. Okay, so they're just basically getting that switched polarity. Here is the rear window switches, and this is the driver's door switch, the master switch. So I suggested to you that power door locks, power seats, power windows are more often than not, both leads, when you do not touch any switch, are connected to ground. So it's a very quick and easy way to start dividing and conquering this circuit, because you can literally split in half your problem in very short order. So let's take a look at this orange circuit. I suggest to you it's connected to ground. Let's follow it up. It goes through this switch. We haven't touched it. We're not pushing up or down. All right, it's gone all the way up. Now you're at the master switch. It goes through this switch. So this contact has to be good. We will have at least checked that much. Through here, through the window lockout switch. That prevents everyone else in the vehicle other than the driver from operating power windows. All right, and it goes to ground. And let's take a look at the other side. As you probably guessed, that's up here, through this side of the switch, and to ground. You can test this power window in a Hyundai exactly the same effectively as you can this Chrysler Concorde power seat. Now let's move over to a power door lock for a 2007 Chevy Cobalt. So you have relays here, but here's your driver's door locks here. And there's a bunch of relays going on. Now this is buried, you can see this color here, it's buried inside the BCM. But all you're checking for is the circuitry of the motor itself. Let's just follow this one. Pin 3 here, all the way up to A4, it goes up through this door lock relay. Okay, now this is a 5-pin relay, and it's going through the normally closed set of contacts, so you're not touching anything. You're not touching any of the buttons. It goes up, it goes to ground. Let's grab the other one. Pin 2 up to A1 here. Connects to this other line coming in from another door lock. It goes up to the unlock relay this time through the normally closed set of contacts over, and it's sharing that same ground again. And you'll notice that's the same for all 3 of these door lock motors. So again, you can test this the exact same way, and I'll take you way back even further, and we'll take a look at a 2005 Chevy Cavalier door lock, and you'll see they have another set of relays here. Here's a couple of your motors. Let's take this top one, the tan pin A, through this door unlock relay over to ground. Pin B goes through the door lock relay over to ground. When you're not touching anything, these relays in their naturally de-energized state. So like I had mentioned at the beginning of the video, this type of very quick testing, it can test a whole lot of the circuitry very, very quick. The only thing you have to remember in these cases is you actually need to isolate the part of the circuit that you intended to test so it doesn't backfeed and it starts giving you false readings where it doesn't look like there's a fault. But there is, but you can't tell on the voltmeter. And the reason why is you haven't isolated that circuit. Isolate that circuit and the problem instantly basically jumps in your face, raises the flag and says, here I am. And you can see how useful this is. It tests a whole lot of accessories and a whole lot of different makes and models of vehicles.